In section 3.3, we're going to talk about how to find the standard deviation of a data set. So first, we're going to explore a little bit about why we need standard deviation. Okay, so we have two manufacturers who are manufacturing 2-inch bolts. Okay, so we've got manufacturer A and a sample of 5 of their bolts. They're 2-inch bolts. You know, they're not exactly 2 inches. One was 2.02 inches, one was 2.01, 1.96, 2.0 exactly, and 2.01. Okay, then we've got manufacturer B who's trying to make these same bolts, and their bolts were 2.2, 1.7, 1.85, 2.1, and 2.15. So first we want to find the average of each of these. We're trying to decide who's doing a better job. Now, if you add up these 5 values and divide by 5, we'll see that the mean is actually 2 exactly. So, on average, they are hitting their 2-inch mark. Now, since these were given 2 decimal places, our rounding rule says we do 3 decimal places, so 2.000 inches. Now, if we look at the manufacturer B bolts, and we take the average there, we would add all 5 up and divide by 5. And when we do this, again, we get 2.0 exactly, so 2.000. So here their averages are the same, so we can't just look at average, which is kind of the point. They're both neat, but who's doing a better job? Now we'll notice manufacturer A, they're much, much closer, each bolt, to 2 inches than manufacturer B. So I think we'd agree that manufacturer A is doing a better job because theirs are closer. Okay, so we're going to look at one more example. So now we're talking about waiting time at a bank. So bank A has 3 tellers and each teller has a line. So we look at 6 customers who go in and how long they waited. So one customer waited 2 minutes, 8 minutes, 6 minutes, 3 minutes, 1 minute, and 10 minutes. So one person got really lucky with 1 minute, one person unfortunately had to wait until 10 minutes. And if we take an average, we see that they waited on average 5 minutes. And we'll put 5.0 because of our rounding rule. Now on the next page, let's look at bank B. They only have 1 customer line, okay? And so their waiting time was 3, 5, 7, 4, 5, and 6. And if you take the average of those 5 numbers, again, we get 5 minutes. So we see that, again, even though they had different ways, their averages were the same. Now, which bank would you rather be at? I think you'd rather be at bank B because, even though one person got really lucky at bank A and only had to wait 1 minute, one person got really unlucky and had to wait 10 minutes. And you can see from bank B, everybody was within 2 minutes of the average of 5. Okay, so we really want to know how spread apart things are, not just what their averages are. And that's the whole idea behind standard deviation. So the standard deviation of a set of values measures what's called spread, okay, or how far apart things vary. So what we're really saying, what it's really measuring is how far apart, how far on average the data values are from the mean. So we're talking about, on average, how far are they from the average? So what this means is the larger the standard deviation, the more spread out the data values are. Now what this means, if the standard deviation is 0, that means they're not spread out at all. And what that means is that all the data values are exactly the same number because they're not spread out. So if it was something close to 0, they wouldn't be exactly the same number, but they'd be close to the same number. Okay, so now we get new symbols for standard deviation. So the standard deviation, the symbol for a sample is just x. Now on your calculator, the symbol they use is s with a little x by it. And the formula, okay, is s equals the square root, and then we're going to add up x minus the mean squared, all divided by n minus 1. Okay, so it's kind of a complicated formula. We won't want to do this by hand. I'll show you one example by hand, and then you'll really want to do it on your calculator. And you can find the standard deviation the same way you found the mean, by going to L1 and then going to one variable stats. So just like we rounded the mean, we're going to round the standard deviation to one more decimal place. Than the data has. Okay, so we're going to look here at the sample of times that 4 students took on a quiz. So one student took 5 minutes, one took 8, one took 11, and one took 36. Okay, so to do it by hand, the first thing we need to do is find the average. And if you find the average of these 4 values by adding them up and dividing by 4, we get an average of 15. Okay, now we need to, for each x value, we need to find x minus x bar. Okay, because we're going to add all those up. So we would take 5 minus 15, which would be negative 10. We would take 8 minus 15, which would be negative 7. 11 minus 15 is equal to 4. And 36 minus 15 is equal to 21. Now, we need to square all of these values, so we'll square them. So we're going to have 100, that's negative 10 squared, negative 7 squared is 49, 4 squared is 16, and 21 squared is 441. Now, the summation symbol says you're going to add up x minus x bar squared. So we want to add up all those numbers. When we add all them up, we get 606. Okay, now, so the next part, if we look at the next part of the formula, it's saying add all them up, what we just got, and divide that by n minus 1. So our n was 4, that's how many we have, so n minus 1 is going to be 3. So we're going to take 606 divided by 3. So that would give us 202. And then the last part of the formula is the square root of all of that. So our answer would be the square root of 202. We want to take this to one decimal place, so we would get 14.2. Okay, and you can see this is a long process just for 4 numbers. Imagine if you had 20 numbers, you really wouldn't want to do it by hand. So you really want to learn how to do it on your calculator. So on your calculator, it's the same way you found the mean and the median. You go to L1, so you're going to hit Stat, and then Edit, and put the data values in L1, and then you hit Stat again, you arrow over to Calc, and then you do one variable stats. Okay, so now we'll talk about the standard deviation for a population. So the symbol is a lowercase Greek sigma. So I know we already had a Greek sigma, but this is a lowercase one. Okay, and again on the calculator, you're going to have a sigma and an x. So you will want to be careful on the calculator whether you're looking for the standard deviation of a sample, which will be, I'd say, 90% of the time, or of a population, so you get the right one. Now the formula is just as fun. So the formula, which again, most of the time you do not want to do this by hand, you want to use your calculator, but the formula is sigma equals the square root of sigma of x minus mu, because now we've got the mean of the whole population squared over capital N. Okay. Now, a good rough guess, if you were, on a deserted island and you needed to find a standard deviation, or, you just want to kind of guess in your head. So a rough guess, and this is really if it happened to be a nice bell curve, it would be the best guess, but is taking the range. So remember that was the maximum minus the minimum value and dividing it by 4. Okay, I'm not really sure why this works, but it just gives you a good rough guess. Now, something that we'll be using quite a bit is what's called the range rule of thumb, and we want to find in a data set, is some number considered unusual? Okay, and what is usual? So we're going to find what would be the maximum usual value and the minimum usual value. So the smallest value that would be considered usual, to find what that is, kind of our cutoff score, is going to be the mean minus 2 times the standard deviation. So we would find that number, and then any number less than that would be unusual. The maximum usual value is going to be x bar, the mean, plus 2 times the standard deviation. So that'll give us an upper limit, and anything bigger than that would be considered unusual. Okay, so we'll do an example here. So it says, the following sample is made up blanks of 16 randomly chosen phone calls made by employees at a particular place of business. So just how long were their phone calls? Okay, so the first thing we need to do is find the mean and the standard deviation. So you can pause this and take a minute and do it on your calculator, but we should find that the mean is 23.4 and the standard deviation is 11.6. Okay, then we want to find the maximum and the minimum usual value. So the minimum usual value is going to be equal to 23.4, the mean, minus 2 times the standard deviation, 11.6. Remember, our formula is x bar minus 2s. Okay, and that gives us 0.2 minutes. So anything shorter than 0.2 minutes would be considered unusual. Okay, our maximum usual value, remember we take our mean plus 2 times the standard deviation. So here we would take 23.4 plus 2 times 11.6. And this gives us 46.6 minutes. So what this tells us is anything between 0.2 minutes and 46.6 minutes would be considered usual in this case. So would it be unusual for a call to last 3 minutes? No, because it falls in that range. So just by looking at that, 3 looks really small if you're just looking at the numbers. It might seem unusual, but statistically, it's not. Okay, now we've got one other rule, and this only works for bell-shaped distributions. This is called our empirical rule. Okay, the empirical rule says that 68% of the data is within 1 standard deviation of the mean. So what this means is that 68% of the values would be between x bar minus s and x bar plus s. So instead of taking 2 standard deviations like we did on the previous page, we're just taking 1. So a bell-shaped distribution, remember, looks like our nice normal curve. The mean is always in the middle. And we're saying if we subtract 1 standard deviation from that and we add 1, within that part, we get 68% of the data. Okay. Now the second part says that 95% of the data is within 2 standard deviations of the mean. And this is really what our usual values mean. So we're saying it's usual if it's within 90%. Okay, so these are our usual values. So their interval is x bar minus 2s and x bar plus 2s. Okay, and if we went out further in our drawing by 1 standard deviation, we'd have 95%. And now if we go out 3 standard deviations, we get 99.7% of the data. So if we subtracted 3s and added 3s, we'd get 99.7. So we're saying that 99.7 of the data is between x bar minus 3s and x bar plus 3s. Okay, so it would be very unusual for a normal distribution for something to be outside 3 standard deviations of the mean. So that's the empirical rule. It just tells us within so many standard deviations of the mean, how much is the data. Okay, variance is another term you'll see. Okay, and variance just means the standard deviation squared. So whenever you're trying to find it, you don't get it on the calculator, but you would get the standard deviation and you would square it. So for a population, the variance, you just take sigma and you square it. Or for a sample, you would take s and square it. Okay, so you would just take the number from the calculator and you would square it. So from example 1, the standard deviation was 14.2 earlier on when we were talking about, what were we talking about? We had the 4 students that took a quiz. Okay, so if we want to know the variance, which doesn't have a special symbol, but the variance would just be equal to 14.2 squared. So there we would get 201.6.